Good afternoon, dear students. Can you hear me? Okay. Thank you. Thank you for feedback. So then let's continue for our next week lesson. We were talking about sensors, and we were staying at the point of pneumatic sensors. So let's share the screen.
Hocam.
Yes.
Hocam sınavlar online görülmüş ama bir değişiklik olmayacak değil mi sonradan?
Sınav nasıl?
The administrative announced that exams will be online.
I didn't see that. So according to my information, the exams will be face-to-face. It is between 10 and 14 April. Yes.
Maybe it will change.
No, but okay, I will check it. But according to my information, the exams will be face-to-face because beginning of or at end of the April, the situation will be re-evaluated and maybe the lessons will start face-to-face, not will continue on online. But we don't know for the time being, so we will wait till end of the March. It will be clear, but the exams must be face-to-face.
But Doctor, today they announced the schedule for midterm, and they write as a classroom number. It's all the exams are online. They announced it today, so I don't know.
Well, I will check. I don't know. Okay.
Okay, Doctor. If you have any information later, please send email to us.
Okay, if there's any change regarding the exam face-to-face or online, according to my knowledge, it's face-to-face. But if it is changed, and they decide it must be online, okay, you will be informed. So, okay, let's start. Okay. So, can you see the slides? Okay, then continue. So last week we started to talk about the sensors, and we already learned that sensors mainly consist of digital sensor and analog sensors, and then there are different type of sensor depending on the applications, like magnetic sensor, inductive sensor, capacitive sensor, ultrasonic sensor, optical sensors, and finally we were at that point, the pneumatic sensors. So today's we will talk about the pneumatic sensor. You know the pneumatic technology, actually, and you know also the pneumatic energy. What we mean if we say pneumatic energy. So pneumatic sensors use pneumatic energy. That means pressurized air, and there are some cases where we preferred used pneumatic sensors. So with pneumatic proximity sensors, the presence or absence, like an object is presence or absence of an object, is detected by means of contactless sensing with air jets. So a signal pressure change occurs with which is further processed. So advantages of a pneumatic sensors, we will see in the application. So how does it work? I will show some applications. So what is the advantages of pneumatic sensors? The advantages are operational safety in dusty environment. So if it is in dusty environment, like metal dust for the inductive sensor is dangerous, or capacitive sensor is also dangerous. So the dust, the pneumatic sensor is not sensitive against the dusty environment. So operational safety with high ambient temperature. So it's also not sensitive about the temperature. So can be used in areas of explosion hazards. So that means if electric is a problem because of the arc contacting and so on, we can use the pneumatic sensors, say in areas of explosion hazards, and insensitive to magnetic influence and sound waves. So pneumatic sensors are also insensitive to magnetic influence and the sound waves, and reliable even in extreme ambient brightness and for sensing of light transparent objects. So those are the advantages. Of course, there are also some maybe types of pneumatic sensors, like back pressure sensors and reflex sensors and air barrier sensors, and like let's say the optical sensors, but we don't use the electric energy in pneumatic sensors. We use pressurized air. So detectable distance range from 0 till 100 millimeters. So detectable. Okay, let's see the pictures from pneumatic sensors. You see here, this is a back pressure sensor, and back pressure sensors, let's use that. So back pressure sensors, and here the distance is 0, and here also 0, and P is pressurized air come in, and the reflected pressurized air goes out. So in and out, you see pressurized air and the answer. Pressurized air and the reflection, I mean here. So you see the distance is 0.5 millimeter, and this we call back pressure sensor. That means there is a let's use another color here. There is a let's say the barrier, and if we apply the pressurized air like this, let's use the color. All right, so if we apply the pressurized air to this surface, then it reflects from here back, and we sense the back pressure. So this is the A, and this is the P, pressurized air, and this is the answer for that. So let's use the yellow one. So this is the back pressure sensors, and this is the reflex sensors. The reflex also reflected by a surface, and the same principle. And here we have air barriers. That means we have the sensor consists of two parts. One of them is the sender, the other one is the receiver, or emitter and receiver. So here we have the pressurized air, here we have the pressurized air, but also the answer. And in between, if there's a material, an object, we can detect it. So let's check the working principle of back pressure sensor. You see the pressurized air come in here, like this, come in here, so, and flow into the object here. And if there's a, you see here this sealing element, seal here, the black one. And if there's an object in front of the sensors, like sorry, let's say like this here, and the pressurized air cannot go through, so it reflects from the object, like this here. So here come in, and there is no way out, and then let's say this is the income here, and then reflects in this direction. So since there's a pressure in that direction, so, and there is a here, the section, cross section is here is reduced because the pressure cannot go back. So we need the pressure here. That means if the back flow in back direction, it is has a resistance and not allowed. Actually, it's difficult to flow in back direction. So it has to flow in that direction, and that if it is flowing in that direction, so we using a sensitive, let's say the membrane or any pressure feeler, so we can detect that there is an object in front of the sensor. So so the back pressure sensors also we can use for the application where we want to check the let's say the niveau of the water or fluidic, any fluidic. So if let's say if the sensor is, for example, here the pressurized part in the fluidic, so then the air cannot flow, let's say, easily. So there is a resistance coming from the fluid or the fluidic. So then we can immediately the pressure can come back and go in that direction. So then there is a pneumatic electric converter. That means the pneumatic signals converted into the electric signals via the contact here, or open contact. So then we can get signals so that there is an object doesn't allow to flow the pressurized air. So in that way, using this principle of the air, we can check is water arrived the say the maximum level or not. Level of the water can be checked. Okay, then reflex sensor means so reflected from an object, and you see here this is the pressurized air coming in here. So let's use the so the pressurized air here flow in here, so in that direction, and here, so going in that direction, so like this, and so on. And if there is an object here, so the you see the air come here, is from here, go also to the side, of course, but So partly go in that direction, pressurized air, or in that direction here. So, and we have get the answer that there is an object in front of the sensor reflected the pressurized air. So then we can understand that the pressurized air sensor detect any object. And of course, we can convert the pneumatic signals into the electric signals. It is also not difficult. There is converter like this. We have, let's say, here the pressurized air, our pressurized air. So, and this pressurized air can, let's say, operate a piston like this, and then piston can operate a contact like here, normal open contact. So, and then let's say we have here, let's use the red color here, 24 volt, 24 volt direct current plus, and here we have, let's say, the signals going in that direction. So if the pressurized air operate the piston, and the piston let's say connected somehow to the bottom here, to the open contact, and then it gets closed like this, and then we get the signals. So then that means we convert the pneumatic signals into the electric signals. Because in control system we cannot use pneumatic signals. In control system we have electricity and 24 volt control voltage. So therefore, in case of we have to use the signals in control system, it must be converted into the electric signals. So there is here an example for the reflex sensor. As you see here, there's reflex sensor. So like this here, there is a paper or anything. I mean, here you see. So okay, here. These are the paper or sheet metal, could be sheet metal. So any flowable material like this. And we have sensors here. So those are our sensors here located. The sensors, and you see if there is a problem with the axis of this rolling part, like this is the axis here, you know, this going through here. So it must, the axis must be really horizontal. So that means if you have a problem with the axis regarding the parallelity, so this is the axis here, and regarding parallelity, that means the band can move in that direction or in that direction. So, and this is not allowed. This we don't like. So therefore, this sensor, the two sensors are checking the edge of this sheet metal or the paper, and that means the sensor has to check the edge of the paper or the material flowing, and this also. So then, if there is, let's say, the paper or the sheet metal moves in that direction, then this will give signals and say, I don't see the material. Or if in that direction, this sensor will give the signal and say, I don't see the material. So in that case, we can adjust this axis here. There's a mechanism, and this mechanism can adjust up and down. So in that direction, can adjust the position of the axis so that the material, say the sheet metal or the paper, can flow properly. Okay. So the air barrier, another pneumatic sensor is the air barrier, like you see here. Air barrier, and the air come, so in that direction here, this is the pressurized air and can flow, that's back in that direction here, and the same here. On the opposite on the opposite direction, that means the sensor consists of two parts. In this part, we have the pressurized air, like this, come in, and the pressurized air can go through here. So if there is an object here, so cannot go through, so then we can check it. So this air can go through, and if it is like the light barrier sensor. And we can use these type of sensors, for example, to check any object. Is it broken or is it okay? So you can imagine if it is, so we can put opposite to each other the heads of the sensors, and then if this part gets broken here somewhere, so then the communication between sensors established, so then we can understand that there is no object in between, so the sender signals can get from the receiver. So then we easily understand that let's say in this example tool is broken. Okay, so once more, so pneumatic sensors we use mainly in a let's say the problematic environment like dust and heat and maybe the electricity is a problem and so on because of the explosion. And in those cases, we prefer to use the pneumatic sensors. One of these applications I used when I was working in a company in Germany to check the material. So to check the material, is it material existing or not? Material checking. So you can imagine. So there's a surface like this. So in this surface, there is a material on this surface. This the surface could be the material. Let's say it's a material. So a cylindrical shape like this. So, and this is the material, and we want to check whether it is so. Let's correct it a little bit. So let's and let's think there is a cylindric gap here, and we want to check whether this material is existing or not. The material, let's use a color, okay. Not this one, the yellow one. So this is the material we want to check. Okay. And there's a gap under this material, under the surface. So, and we can use a sensor, a pneumatic sensor under these. So this is the sensor. Maybe we can use here this sensor here, like this one, huh? And the sensor goes through here and send the air to this material. And if the material is on the surface, it reflects the pressurized air back to the sensors and the back pressure sensor. Like the back pressure sensor, we can check whether the material is there or not. And of course, the surface must be very clean, very smooth, so that we can detect with pneumatic sensors this material. And it doesn't need any electricity. Of course, it needs the pressurized air, huh? Has to be connected, but doesn't need electricity or hydraulic or anything else. Quite robust, and we use. Or another application. So another application we have here. Here you see this is our sensor here, the big air barrier sensors. And the other sensor is in front, is on the opposite in front of this part. So if there is a sheet metal, let's say, goes in between, like let's say this is the sheet metal here, or paper or anything is flowing. So then you can easily imagine that the material interrupt the communication between the sensor while the pressure is there. So then the sensor can give signals and say, so there is something I detected. It's also the way how can we use the pressurized air. Huh? So those are the materials. Could be sheet metal or the paper or anything, depending on the application. Okay. Here we use also the air barrier, sensor air barrier, and to check, let's say this is a cam, and you see the part of the cam here, like this is the part. So the pressurized air can detect this part. And on the other part, I mean, here there is a, I mean, the difference regarding the radius. I use that, and we have here the radius, and this is this radius here, you see. So then we use the sensor to detect this part. So this part, sorry, this is also possible. Okay, so pressure switch, as I mentioned already, pressure switch, that means we convert the pneumatic signals into the electric signals. And you see here the picture and how does it work. So here we have pressurized air. Here the pressurized air. So the P. So act on this membrane, and this membrane, behind of this membrane, there is a piston or there's a mechanical part, and this mechanical part you see with spring pushed in that direction. But this is, I mean, this is operated, operated picture. This is not operated picture. If there is no pressurized air here, so let's use the point sensor, laser pointer. So if there is no pressure here, you see, because of this spring, the piston is in advanced stroke. And you see this membrane is moved outwards. So if we apply the pressure, and you see the contact here, the contact is here. So let's use the okay, this one. So you see, this is the contact here, huh? Normally closed. This is normally closed, huh? Normally closed. That means we apply here 24 volts, and this is normally open. And if we apply the pressurized air like this here, the pressurized air, you see the pressurized air here in that direction. So then piston moves back against the spring force. And then the contact change, you see here. Look, contact is changing. So then we get electrical signals. So we get electrical signals. And there's a coil here. Now you see the coil here connected to get the electric signal. And this is the symbol. And the symbols means we have here 14 signals. 14 signal is a pressurized air. And this pressurized air, there is an amplifier inside. Here, this triangle shows there is an amplifier. And it operates a contact group here, maybe a double contact, normally closed and normally open. And then we get the signals against the pressure, and pressure signals, pneumatic signals. And the level of the operation can be adjusted. That means if we want to get you see the spring here, spring against the force coming from the pressurized air. You see the pressurized air affect this surface, and the surface is like this, and then it creates a force coming from the pressurized air. Huh? The pressure times this surface, area of the surface. So we have here the force coming from the pressurized air, then multiplied by the surface. And on the other side, we have here the force spring. So then if it is in balance, so if there is no force from the air side, so the pressure spring push to the outside, the piston, and the contact is in that point. So if there is a pressurized air applied, so then the force coming from the pressurized air and the surface here against the spring force. So the spring force is not so high to keep the pressurized air in balance. And then the moves in initial position or in the back position. So then we get the contact here again. And by adjusting this spring, you can imagine, by adjusting this spring, we can actually adjust the level of the signals. So we can see this is here the arrow means maybe we arrive to the 2 bar, we get the signals if there are 2 bars, or 3 bar, or 4 bar, or 5 bar, depends. So it's a nice component to convert the pneumatic signals into the electrical signals, and not constant. We can adjust the level of the signals to get the signals, and we get the signals on-off signals. That means existing or not existing. But we can define the level of the pressure for the signals. If you want to get the signals for in case of 2 bars, then we can adjust the by arrow using the arrow, or 3 bars, or 4 or 5 bars. So then we will talk now about the pressure switches. So this switch we learned already here. So the pressure switch, this is also a type of sensor. Therefore, you see these signals here, sensor signals like this. This is sensor signals. Huh? So, and you see also contact here. Normally open like this. Eh? Normally open like this. So this is any other sensors. It works like any other sensors, but we have here 2 cable. One cable, 2-wire technology. This is the 2-wire technology. And 2 cable, that means one of them is the brown, and this is the (24 volt), let's say, here connected 24-volt direct current, positive, and the other part is the negative. So it continues like the red one here to the last, I mean to the let's say the light or coil or anything we use in our control system, and this is the blue part like this. Huh? Okay. So the one side we apply the sensor to 24-volt direct current like this here, and then if the contact gets close because of the switching of the sensors, then we get the current like this, and to the object here like coil or light or anything, so it works then. And there are 2 types. We can put the last in this part of the circuit or in this part of the circuit. But it's brown, still brown and blue here. Down is blue and this brown. I mean the 24-volt direct current, other ones the connecting to the earth. So this was 2-wire technology. So this is important to know, 2-wire. Oh. 2-wire technology. That means there is 2 wires here. So, and the next we will discuss 3-wire technologies. 3-wire technologies. So that means sensor has 3 wires like this. And the first one is the red one here like this, brown, 24-volt direct current. and the other one is the blue. So the blue is the ground to 0, and the black is the cable deliver the signals from the sensors. Let's choose this, the black one. So, okay. So, it's too much, huh? So, it's much more better. So, we have a 24 volt. It is an electronic device. I mean, sensor in this case is not a pressure sensor or pressure let's say pressure sensor like this, pressure switch is correct. It's not sensor, it's a switch. But you know, even if it is switch, they use the sensor sign here because it works like a sensor, deliver signals, and that's the reason actually why they use the sensor sign here. But this is a switch. Switch means switch are working about in a contact. So this is like, so we have here the 24 volt and connected to the normal open or close contact, and then goes wider, goes so through. So here 24 volt, and here maybe if you have a light or anything here like this. So this is the ground part, 0 volt, huh? And this is here 24 volt, 24 volt direct current and plus. So this is a switch, and the pressure switch works like this. But the connections, if we talk about the sensors like inductive, capacitive, or optic sensors, they have, since they are electronic equipment, they have 3 cables or 3-wire technology. One of them is the connection to the 24 volt direct current. The other one is the connection to the ground, 0 volt, and the black one, and it's also colored and standardized. So the standard is also important. I mean, the color are standardized, and the black one is for the signals. If sensor is active, then if the sensor detects something, the sensor deliver the signals, and then we use these signals, for example, for the coil or for any other object. And we can, there is 2 different type of 3-wire technology. So one of them is the, I'll show now, PNP normally open. As you see here, this contact is normally open. What is PNP? That means positive, negative, positive. So here, the last is, the object is connected from the positive to the ground. And this is also PNP. We have also NPN, and we will see in our next examples PNP. This is also PNP, but this is normally close contact. That means if sensor detects something, sensor doesn't deliver the signals. And here, if sensor detects something, sensor delivers signals, because normally open. If sensor detects something, gets closed, the contact gets closed and deliver the signals. And here in this example, here is normally close contact, as you see, and that means if sensor doesn't see anything, sensor is supplying the signals, and black cable is already supplying the signals. But if sensor detects something, the signal is not more available. So we can use in that way, signal available or not available, is also for us enough as information. But we should know actually it comes from the contact. Is it normally open or is it normally closed contact? So let's make break 15 minutes and we will start again 14:15. Huh? Okay, let's start. Huh? The three-wire technology, we discussed the three-wire technology, and then PNP sensor, of course. Huh? So here it was PNP. Wait 1 second. Okay. Here and there. So PNP sensors we discussed. Now the NPN sensor. Here you see the NPN, negative, positive, negative. So normally open and normally close contact. So you see here the normally closed contact, and here we have normally open contact like this. So what means NPN? NPN means the last, I mean the L is the last, or let's say any component from the control circuits has to be connected between the positive and the signals cable. So that means between brown, let's choose this color brown, we have the brown. No, I don't know the brown. Brown is not available. Scale tone. No. Okay. So let's use that. Okay. It is the brown one. This is the okay, and this is the black, and this is the blue. Blue we can here check. We can this is the blue one. So the last is in between. I mean the object could be coil or any light and so on. It must be in between. I'm between 24 volt and the black cable, signals cable. And here also the same. But what is the difference in between? Here we have here the normally, let's say here normally open contact. Here in these sensors, here we have here normally closed contact, as you see here. Normally closed contact. So against three cable. The red one, blue one, and the black one. And the last is connected, in this case, between the black and the blue. Here, use another color, maybe it's important. Use in between here. You see the coil or the light has to be connected between black and blue. And here, in that case, PNP, okay, NPN, sorry, in NPN, between 24 volt and the black, PNP, in case of PNP, between black cable and the blue cable, okay? So this is the main difference. Okay, so then let's come to the four-wire technology. So the four-wire technology, what means four-wire technology? The four-wire technology, there are sensors which has 4 wires, like here, brown, black, white, and the blue. So where does it come? Again, we differentiate between PNP, normally open, or normally closed contact, and NPN, normally close contact. So here, as you see, we have 4 cables. This is the main issue: brown, black, white, and blue. So what does it mean? So depending on which type of signal we are going to use in the control system, because the sensors are delivering the signals to the control system, and we use in processing part of control system the signals in processing. Here we have, and let's use the here. Here we have, you see, the normally open contact, like this. And here we have normally close contact in the same sensor, same sensor. And normally open contact has white cable, and normally closed contact has blue cable. So, and that means if we use the normal open contact, then we have to oh no, not that. So we have to use as the coil or light for normal close contact, and this is the for normal open contact. So if we use normal open contact, we use, let's say, the cable black, brown, and blue. If we want to use the normally closed contact, we have to use brown, white, and blue. So brown in any case, in any case, always brown we have to, because this is the 24 volt direct current. And for the normal open contact, we use brown, black, blue, and for normally closed contact, brown, white, and blue. So this is the same here. And this is here PNP, and this is NPN. So NPN. So you see where we connect the last, the coil or the light, the location is changing depending on the PNP or NPN, positive, negative, positive, or negative, positive, negative. But if we have 4 cables, so the reason is we have 2 contacts at the same in the same sensors. One of them is normal open, the other one is normally closed. Depending on the control, the expectation from the control sides, we can use normal open contact or normally closed contact, or both of them as signal element. Okay, so parallel and series connections. So in sense, we are slowly changing over to the signal processing. So what means parallel and series connections regarding the contact or sensor let's say sensor signals? And usually, let's use the yellow one. So usually logic operations of the proximity sensors are carried out by the controller. I mean, the controller has such a facilities or offers such opportunities, so we can create different logic operation or logic connections using the facilities or opportunities of controller. But by means of the series or parallel connections, it is possible to achieve the logic operations of several sensors. So with parallel connections, it is possible to effect a logic OR. Let's see, logic OR connections, and with serial connections, a logic AND connections. So that means and OR. I'm sure you have heard till now what means that. So or what is OR logic operation, or what is AND logic operations. So if we let's draw a circuit here, small circuit, and see what's AND and what's OR. So let's say we have here the 24 volt current, 24 volt direct current, positive, and here we have ground, that means the 0 volt somewhere here. And this is 0 volt. Huh? So, and if we connect two contact like this, two contacts like this, one of them is this one and the other one is this one, and let's say this is S1 and this is S2, two contact, and connected to the ground like this here. So if let's use the black one, this is our contacts here. S1, our contact like this, push button. So also push button, this is S2. So I made a mistake, I have to correct it, take it away. So here I will use a light like this here. There's a light here, huh? So use, and this is connected, let's say, to the blue one, to the ground. So when the light gets on, in which situation? So we can establish a table here like this. Let's say this is S1 and this is S2. And here we have our light. And the light we can indicate with H. So H. So here like this is the H. So we have four situations actually. Like this. We can have the S1, that means we push the button. That means S1 is 1. We don't push the button S2, it is 0. And we don't push the S1, and we can push S2, or we can push both of them, S1 and S2, or we don't push both of them. Both of them are 0. So the light, the result is if we check here, so that the light gets on. So it must be both of them operated. Like here we have 1. And here is the 0. The result is 0. Output is 0. We have only one output, which is 1. And the case is both S1 and S2 must be operated, must be pushed. Then we have 1. That means the light gets on. Light gets on. So this is an AND connection or AND gate. AND logic. So AND logic AND. So this we can call logic AND. Logic AND. So logic AND. What means OR, and how is the circuit regarding the OR? So regarding the OR, we can say, okay, let's use that. We have S1 here, S2 here, and we connect all of them. And here somewhere we have our light, and then the blue connections here, like this. So our light is somewhere here located. This is the H, light. And here our push button, normally open contact, of course. Here, this is S1, and here, S1, and here, again, normal open contact, push button, S2, S2. So let's create a table here, and let's have 1, 2, and 3. So this is our S1, and this is S2 button, and this is our light. So again, we have 4 different situations. And those different situations like this. If S1 is pushed, that means it's 1, and the other is 0. And if it could be, if S1 is 0 and the S2 is 1, or both of them is 1, or both of them are 0. That means not operated, not pushed. So this is logic AND. We are writing now logic OR. Logic OR. So OR. So then here we have OR means whether or. You can look at this circuit here. If I push S1, light gets on because we will get the 24 volt via these connections. So that means if I push S1 and don't push S2, the light gets on. That means we have here 1. Light gets on. If I push S2 and don't push S1, light gets again on. And this is also 1. Or if I push both of them, again, this is 1, get light. If I don't push anyone, don't operate any one of them, this is 0. That means this is logic OR. So we have in logic OR, if we connect 2 signals with logic OR, so it means at least 2 signals has to be connected. So in case of AND or. So then we have in 3 cases, in logic OR, 3 cases light on, in 1, 0. And in AND operations and logic AND, we have only 1 case where we get light on. You can, I can show you that also. Using, let's say, we can make a simulation and I can show you. I hope it works. Okay, it works. It seems it works. So let's take it away. Okay, now here, let's establish the circuits. Here we have 24 volt. So 24 volt, okay. And here we have our 0 volt. And let's establish the contact. Where is the contacts here? So normally open. And this is S1. S1 normally open, okay. So, and then let's copy and paste. I hope let's, okay, S2, right, okay, it's correct. And a light we need somewhere. Light, where is it? Here, okay, indicator light, okay. Ah, 90 degrees turn. Okay, here. And let's connect them like this. We have connected these two signals element, S1 and S2 in series, you see, in series. So then if you start the simulation, so if I push S1, light doesn't get on. If I push S2, also light doesn't get on. But if I push both of them, I mean S1 and S2, you see light gets on. There's in case and there is only one case. So S1 and S2 must be operated at the same time, or I mean must be operated to get the output 1. But in case of parallel connections, let's use this and let's establish the other and parallel connections here. So, and then one more, copy and paste here like this. Okay, here we connect parallel to connect two signals element, S2 and so. Okay, and the light has to, we need also the light here, and is somewhere here. Okay, so then it has to be also connected to the here. Okay, and this like this connected parallel. Okay, let's see that what's happen. So in case and OR connections, here we have OR connections. One of them is enough of these signals S3 and S4 to get lights on. So you see, if I push this button, light gets on. S4 is not operated. If I push S4, lights again gets on. So this is the OR connections, S3 or S4. One of them is enough to get the light on. But if we connect in series, two of them must be operated. One of them is not enough to turn the light on. Okay, let's come to the PowerPoint presentation. So this is the logic AND table, and this is logic OR table. So it is not so complicated. I hope you understood that. Then let's continue. Parallel and series connections. What is the advantages and what is disadvantages? So the advantages and disadvantages. So logic operations can be achieved without using an electrical control, without using an electrical controller. So with the use of electrical controllers, logic operations can be carried out immediately on the spot, so that only the logic operation result is signaled to the controller using a minimum amount of the cabling. So disadvantages: this design and construction of logic operations requires experience, as the mutual influence of proximity sensors increases response and the drop-off times, and a limit in the number of proximity sensors connected must be taken into account. And the other one is the maintenance becomes difficult. Disadvantage: parallel or serial connections. But in control system we use, if we have, if we want to solve this problem, and or connections, logic OR and logic AND. If you use the contact, we can really, using the contact, we can realize this logic AND and logic OR, like I have shown in the simulation. So there are parallel connections here. You see, two sensors or two switch are parallel connected. Again, two-wire technology. Two-wire, that means each sensor has two wires. One of them is the red one here. This is the red one, connected to the 24-volt direct current. And the other one is the blue one. Huh? So this is the blue one here. And this is the signals coming from the sensor. This is a switch, not a sensor. And let's say the red one here come from this blue, come to the light. This is the light here we have, and also here connected to the here, and also the light here. So what type of connection is it? An answer? Let's say this is the sensor or switch 1 and switch 2. Like, if one of them is operated or detect something, and we think there's a light here or anything else, or let's use the, okay, here the light, it gets on if one of them is operated. And therefore, this is the parallel connections, two-wire technology, parallel connections. So the next one must be serial connections. I hope here, okay, yes. And we have here three-wire connections, you see, and parallel connections. Three-wire connections. Here we have the 24-volt direct current, 24-volt direct current, which is connected to the sensor, brown cable, like this, and this is blue connected to the blue one. This is the blue here, you see, and this is also blue connected to the ground, and blue connected to the ground. So, and here this is the three wire connections. So you know the blacks are the signals coming from the sensors, and if these signals come, the light gets on, like this here. Let's say this is the light, our light, connected here. So if one of these sensors are operated, like deliver the signals, light gets on, or here if these sensors operated, light gets on, turn on. So this is again parallel connections, like our previous example. This is 2-wire connections, like a switch, and this is 3-wire connections, like a sensors. Okay, so let's come to the serial connections. Against 2-wire connections. So 2-wire connections, but in serial. What means serial? So we have here 24 volts, 24 volts, direct current, 24 volt, and this is connected by brown cable to this switch. And here we get the signals from the switch if it is operated, if it detects something. Go to the next sensor or switch for the connections, or connect to the brown cable, that means 24 volt. And from this sensor, the current flows into the last. into the light, let's say. So this is the light, our light here. And light gets on. So, or the coil or anything. So, and it is connected to the ground, 0. Okay. This is 2-wire connections with 2 cable, and with, sorry, 2 cable in serial connections with 2-wire technology. Okay, let's serial connections with 3 cable, I guess. Okay, yes, we have serial connections. Again, serial connection. This is the logic end, 3-wire technologies. If you have 3-wire technology, so how can we connect it? It is also not so difficult. We have here our 24 volt direct current. Like this here, you see 24 volt direct current. And this 24 volt direct current connected by brown cable to the, let's say, the sensor 1. And if we get signals from the sensor 1, let's write here sensor 1, and let's choose the color black. This is sensor 1 and the sensor 2. Okay. All of them are connected to the, let's say, the 3 cable. Since it is 3 cable, this is the, oh no. Blue, let's use the blue color. So connected blue one to the ground here. And this is also connected to the brown, say blue. And this is our 0 connections, ground. Okay. So you see the signals are connected in serial. So which are the signals here? So those are the signals. As you see here, the signals are connected. here. These signals is connected to the sensor 2 for 24 volt, because if sensor 1 is active, that means delivers the signal at 24 volt, and this 24 volt is connected to the sensor 2. And if sensor 2 also active, detects something, so it delivers also 24 volt, and this 24 volt is connected to the last, that means the light or coil here, and it can turn on if both of them are operated. Sensor 1 and sensor 2 are operated, then the light gets on. Okay, this is AND connections. This is a column AND connections. AND connections. So 3-wire AND connection. This is also an AND connections, 2-wire, as you see here. Okay, and this was OR connections, 3-wire, OR, logic, OR, and was also OR, 2 wires, operation, logic OR, 2 wires, logic OR, 3 wires, technologies, logic AND with 2 wires, technologies, logic AND with 3 wires, technologies. Okay. So selection criteria. So how can we select? They can be selected according to the material which they are to detect. So first of all, detection, of course, we mean the sensors. How can we detect these sensors? And it is very essential, actually, in industry. If you start your professional life, you will face those type of problems. You will maybe, if you are, let's say, employed in the design department or automation or maintenance and so on, or the project, I'm sure somehow you will face the sensor problem, and you will at least you will be one of the let's say the team has to discuss the sensors application. And then so the question, they can be selected according to material which they are detected. So sensors can be detected according to the material which they are to detect. And the materials of any kind can be detected easily and economically with inductive sensors if short switching distance only are required. So switching distance 0.4, 10 millimeters. Then we can use the economically and functional also the inductive sensor. Inductive sensors. But the metals, very important, metals of any kind can be detected easily and economically with inductive sensors. If short switching distance only are required, like 0.4 and 10 millimeters. For greater distance, optical sensors of wiring design are available. For greater distance, if you have greater distance, then you should think in direction of optical sensors. Of varying designs are available. I mean, you see the optical sensors, we already learned there are 3 types of optical sensors. Light barrier with reflector or without reflector and so on. The greatest distance can be spanned by means of through beam sensors, the greatest distance. That means through beam sensor, you may remember, maybe we can through beam sensors. You may remember the transmitter and receiver are in different body, and so like this. So through beam sensor, this is transmitter and this is the receiver. So if we need a big distance, if you have a big distance, it is recommended that you use the through beam sensors. That means the transmitter and receiver are separated in different head. Okay, through beam sensors, and let's come to the okay. Oh. Capacitive proximity sensors are suitable for the detection of a wide range of material. But capacitive proximity sensors are suitable. So, but again, only for relatively small distance. It is also interesting, relatively small distance, similar to inductive proximity sensors. And ultrasonic and the optical diffuse reflective proximity sensors are able to detect a wide range of different materials, over greater distance. However, the detection or reflecting objects with tilted surface may create problems. So the surface must be smooth, very smooth. Further criteria for selection of proximity sensors are the conditions under which the object is to be detected, what the installation requirements. So what installation requirements for the proximity sensors are, and the environment factors. So installation requirements and the environment factors to be taken into account. So in order to select the sensors, mainly we can say if we want to detect the magnetic field, we use the magnetic sensors. If we want to detect the metal or types or different types of metal, we use the inductive sensors. If we want to detect any materials without air, except air, so then we have to use the capacitive sensors. But we have to also consider the distance, detecting the distance. If we have let's say the wide detection distance, so then the optical sensor, through beam sensor, is recommended. Okay, so the installation requirements and the environment is crucial. So the selection criteria, object materials, and the conditions for the, in summary, so I say the object materials, conditions for detection of objects, installation conditions, environmental conditions, safety applications, and options, features of proximity sensors. Let's have a sensor exercise. But before we do this sensor exercise, we make the break again, 15 minutes break, and then after 15 minutes we meet again. So, and please think about a conveyor transports three different colored workpiece, three different colors. So, workpiece to a short sorting station. At the sorting station, the workpiece will be sorted according to their color and directed to their respective parts. So the workpiece are red. Let's use the red color here. Red. One of them is the red, like this. And the other one is the black. So the black, okay. Black, let's black. Use the black like this here. So, and the other one is metal. Oh, metal. Okay, metal. Let's leave it as metal. Oh, so then how many sensors and which sensors are required at this sorting station? So we have to sort two different colors. One of them is this is metal, the other one is the black, the other one is the red. Metal, you know, is the green. And we have a sorting station, and this sorting station, we have to use some sensor to sort the materials and to sort according to which is red and which is black and which is material and which is metal. So in next lessons, we will discuss that and think about. I will expect some answer from you, solution or your idea. So let's make break, and after, so we'll start 15 past 15. Okay, let's start. So, which type sensors do you need in order to solve this problem? So, any answer? Can you hear me? So, what is your answer? Okay, I will not solve it. You solve it. So, this is the sketch. Here you see we have here different, let's say the different materials. That means different color. This is the red one. So one of them, let's say this is the red one, and then we have, okay, we have black. Let's use another one. This is the black one. And we have metal. Let's say the metal color, I don't know, metal, we don't have the color, metal color here. So let's say here is the metal in between. Huh? This is the metal. So we have to select the sensors, the sorting station for the sorting station, and we have to select the material. And the red one has to go in that direction, the metal in that direction, and the black one in that direction. Okay, we finished this part. So then we turn on. So we turn on to the network. We finished the part sensor, so we start the network. Network. So what means network? So we already discussed the topics, actuator, sensors. Now we are in network, and after network we have hardware and software. So what is network? What is network? You may remember we said, let's have a linear actuator like this, pneumatic linear actuator, and let's have two sensors on the actuators in order to check the position of this piston. This is the one B1, and this is the second sensor to check the advanced position. This is also one B2, and there is a valve we use to drive this piston. Valve is we learned already for two-way valve. So let's establish the connections. So like this. And oh, sorry, this is not correct. Okay, here. Let's say again. So this is like this here. And here also like this. And Here we have these connections, and here we have the exhaust 5 closed. So then use the again the black one. Here this is the connections 4 connected here, connections 4, and here connected, this is 2. And we have here 2 coils. We will show that. This is the connections, pressurized air 1, and this is the connection of exhaust 3, and this is another connections for the other exhaust 5. Okay, let's have 2 coils here. And coil we can indicate with, let's say, with one okay, with this one. We have here, now use different color for the coils. Coils, let's use this one. We have here 1 coil or solenoid here, and the other one is the here. We operate the valve with the electric. That means we have 2 coils. This is here Y1, coil 1, and this is Y2. Okay, so we need a control system for that. So the control system, let's establish the control system. For the control system, this is the power circuit. Control system, for that we need 24 volts direct current, 24 volt direct current plus, and then we need, of course, the blue line here. This is the 0 volt. Okay, then let's establish the circuit. If I push the start 1, this is the start 1. So if I push the start 1, then a Y1 has to be connected here. This is the coil Y1, and if I push this start 2, let's say this is the S1, start 1, and this is S2, and this push button here, then coil 2, this is the coil symbol, and another coil here, this is the coil 2, like this. So, and this is the Y2, coil 2, and let's establish the connections using the different color. This is the, let's say, the red one for the current, and this is also the current here, also connected here and there, and we use the blue color to connect the ground here. Okay, so if I push S1, Y1 will be active and piston moves forward. If I push the S2, then Y2 will be active. So then piston moves in its initial position. And there are signals here. So, and the signals from coil and from sensors, we have also the sensors here. And the sensors, I mean, the sensors has to be also connected to the circuit. And we have to have also the sensor here somewhere, has to be indicated. But I know too much place. I will do it with the simulator. I mean, the simulation software. You will see that, and you will see the network. Network means this is cabling cabling. That means the signal transferring, or way of signals coming from the environment of the machine or going to the environment to the machine. So I'm going to use the simulation software and I will show you that. Here, so let's take it away. Also, this is not needed. So also not needed. But S1, S2 we need, I guess. S1 we need, not S2. Okay, here. So then this is also not needed. Here not needed. Very fast. I can draw the our pneumatic cylinder like this here. Pneumatic cylinder, and that add two sensors. Okay, that's the valve to operate the so to operate the cylinder like this, and properties, okay, configuration, let's select two coil, and manual, not electrical, must be, okay, electric here, also electric. So then finished, and here we need the okay, shock absorber. How was that? Is it hydraulic? Oh, this is terrible. Actually, I wanted not hydraulic, pneumatic. Hydraulic, not those. Pneumatic, I have to use the pneumatic. I did a mistake, sorry. The pneumatic, okay, I have to use the pneumatic. So then the valve from pneumatic, okay. So here, okay, properties, configuration, okay, let's say electrical actuated. So then here the properties, okay, this is the exhaust 3 and exhaust 5 also here, and this is the air. So then let's connect here, there, okay, good. So then move to the side here, and then we need the air, okay, air source. This is the air source here, and we need also one where is it? 3 two-way valve. Where is it? Here, okay. To open the pneumatic energy, to operate, open the pneumatic energy, and we need also the service unit somewhere here. The service unit is also important, so it has to be connected to service unit also. Okay, here, service unit. So we finished our power circuit. This is the power circuit. We have here the pressurized air source, and then service units, and then the turn on, turn off switch, 3 two-way valves to turn on or turn off the pneumatic energy. So, and those are the coil to operate the system, and they say this is the Y1. So the Y1, and this is Y2. We have to address Y2. Address it. So okay, then then the sensors we have to add to the actuator, because we have to check the position of the actuators, actuating labels. Let's see, label 1, B1. It is checking the position, 0 position. Okay, and then 1, B2 is checking the advanced position, 100. Stroke is also 100 here. So then we have the sensors also here. Then let's establish the circuit diagram now, the electrical circuit diagram to control it. So we have here a signals. That means the start signals. Somehow we need a start signals to start and stop. So, but we have also sensors here. So then let's use the sensors. Where is the sensors? Sensors, where can we find the sensors? Somewhere. Okay, here, not. Okay, here we have the magnetic sensor. So this is the magnetic sensors. You see 3 cable sensors, huh? Cable 1, and this is 1B1. You have to give the name. This is 1B1, okay. And we can select PNP or NPN. We select PNP, okay. Then another sensor here. This is 1B2, okay, and has to be connected to the brown cable. That's in the positive 24 volt is also connected, okay. So let's get closer here, and then I need more place here, therefore okay, here a little bit, okay. So then this is the blue line, okay. So then the signal element. Relay, we already talked what is relay, so I need here the relays. Relay, where is the relay? Here, the relay, okay. Relay coil, so then my start signals come here, and I operate the relay here. This is, relay has to have name, and let's say this is the K1. K1. First relay, and I need one more, and this is K2, and K2, second relay, and I need once more, and this is K3. I have to give the name, okay, K3. So this is also okay. So then all these signals, I need for all these signals a relay. So these signals has to be connected here, and then from here to blue line. Also here, the signals has to be connected here. This is the signals cable of the sensors. And also here has to be connected. So, and this the blue one, blue line has to be connected here. And blue line has to be connected to the ground. It's also okay. So I actually, I can move a little bit to the side so that, okay, can be, okay, so, okay. And okay, to the side, and also this is here. So it seems nice. So then I have to decide in which conditions the cylinder has to move forward and in which condition has to move back. So I would like to say, if the cylinder is initial position and I push the button, cylinder moves forward. And then if the cylinder arrives its final positions, piston, and piston has to come back. So therefore, for the Y1, I mean, I need to normally open contact in series. We talk already, we discussed what is series connections, what is parallel connections, all we discussed already. Here, two contacts. One here, and once more. Let's take it a little bit down. Okay, here. This is, you see here, two contact. This is K1. Contact comes from the K1. We can select here because this is already known. K1, okay, and this is K2. K2, I will explain why is it so. K2, okay. This is normal open contact come from the K2, okay. This is a normal open contact belongs to the relay K1, and this is normal open contact belongs to the relay K2, and they are connected in series. So why? Because my idea is, or my expectation from the control system is, if I push the start button, the piston has to move forward. So then, something is missing here. So something is missing. What is missing here? This is the coil of the Y1. So where is the coil? So you have to find the coil. Where are the coils? Somewhere here, valve coils. So let's put it here. Valve coils. And I have to give the name here. This should be Y1. Properties, okay. Y1. Y1 is also defined here. Y1 is also defined, okay. Here I need a little bit place. Okay, then the second, we need, this is circuit 1, circuit 2, circuit 3, and circuit 4, 5, and 6. I need once more. That means if I push the S1, the K1 the coil will be operated, and the contacts of K1, normal open contact, gets closed. And this will get closed. And if piston is initial position, that means B1B sensor is active. If it is active, so then K2 is also active because of these signals given by the sensors. These sensors, so K2 is active. That means the normal open contact gets closed, and Y1 gets signals. That means they activated. If Y1 is activated, so valve take this position and piston moves forward. That means to the advanced stroke. And we will see if it will work in that way. take it so in that direction. So this a little bit. So here I need also some valve to check the speed, to control the speed of the cylinder. One-way speed control valve, where is it? Here. So this is the one-way speed control valve. Let's use it here like this. Oh, I have to turn 100 degrees, rotate 100 degrees. Okay, then. So, okay. So then maybe one more here, same. And then we are able to adjust the speed in advanced stroke, in return stroke. Where is it? Copy and paste here. Okay, here. Connected and here connected. So it's also okay. So then the second line here, we need a little bit place here. So it's okay. So the Y1 will be operated only if B1, B2 is active. If 1, B2 is active, that means the sensor, this piston arrives its advanced position. Then 1 B2 will be active, 1 B2 will be active, then K3 gets active, and I need the normally open contact phone of K3, and the one coil here, this is must be by 2. Properties, this is okay, Y2. Okay, and this is also connected here. And how I am going to operate or to operate the Y2? If K2 is operated, K2, that means I need a normal open contact for, where is it? Not here, okay. Somewhere here. So, like this, okay, here, and this is must be K3. So, okay. And then let's connect. And we have here the circuit line 7. So we have a control system, established a control system, consists of seven circuits. First, second, third, and 5 and 6 and 7. So now we complete the power circuit, which we run with pneumatic energy, and we have here the control circuit, which we run with electrical energy, 24-volt direct current. So let's check whether it's work or not. So you see the sensor B1B is active. Why B1B is active? You see the piston is initial position. Since it is initial position where B1B is located, the B1B is a magnetic sensor, is active because of this reason. Because the piston, there is a magnet on piston. We discussed in our previous lessons when we discussed the pneumatic technology. So, and if I push this, then since B1B is B1 is active, the signals coming from the 1B1 operate the relay K2, and K2 is operated, and the normal open contact on K2 you see here gets closed. And if I push the start button, and the start button will operate the relay K1, and the normal open contact from K1 gets also closed. Then Y1 gets active, and Y1 is the coil of the valve. And if Y1 is active, valve will take this position, and this position means piston moves forward. Let's do that. And if piston arrives its final position, I'm in the advanced position, and then the 1B2 will be active, the sensor 1B2 will be active. And since if 1B2 will be active, this is here the sensor, and then K2 gets active, and K2, that means the normal open contact on K2 gets closed, and then Y2 will be active, and Y2 means piston valve take this position, and this position means piston moves in initial position. Let's do it. So I start. Why it doesn't work? Because it doesn't work, but you see the control system is working. If I push the S1, so Y1 gets turned on. I mean the coil turn on, but the system doesn't. I mean the piston doesn't move because I didn't turn on the pneumatic energy. So I have to turn the pneumatic energy. So if I turn the pneumatic energy, it starts now. You see? So then I reduce the speed a little bit so that you can follow the motion. Let's do it. Moves forward and automatically come back, you see. So return stroke, I have to open a little bit. Okay, so then you see, so then maybe this is okay here. So you see now we have an actuator, linear actuator. We create a linear motion. We can use, let's say, to lift a load in certain position, or to open or to close any door, for example, or any part, mechanical part, to push and to pull. In order to check the position of the linear actuator, we use the sensor here, the position sensors. Those are on-off sensors. That means the signal is on or signal off. The magnitude is not important. We are interested to know, is it 1 or is it 2? That means, is it existing or not existing? And these sensors we use in our control system, you see here. And all these signals from the control unit to the machine, or from the machine, like the sensors, to the control unit, sensors delivering the signals to the control unit, for example, needs a certain way, that means the cable, to transfer the signal. And this is the network. This we call network, to transfer the signals. Today's we'll talk the networks is very important issue. We have very modern network system nowadays in industry used, like Profinet or the other type of communication system, industrial communications way channels, the networks, networking signals. And so I will show you something more here. So you can easily insert rectangular here. So let's say the rectangular here. So those are the input signals. Those are the input signals you see here in this section. So can we do something here? Properties, color, no color. Show all settings. Unfortunately, there's something missing here. The working for page, didactic, manage whole project, display settings. Contact image, now using description. Insert, okay. Draw, no. So the picture, text, object, and unfortunately there is no, and so rotate, mirror properties, delete, paste, add, create cross-reference, no rotate, mirror properties. So actually, in our previous version, it was covered, I mean, labeled, no, show all settings, are valve opening. Okay, so those are the signals, huh? Input signals, S1, 1B1, 1B2 for our control system. Input signals, huh? And do we have here this ellipse? And those are signal processing unit. Signal processing, that means we process the signals here. K1 means S1, K2 means, because it's operated by S1, K2 means signals 1B1, operated by the 1B1 sensor. So these are in serial connected. That means we have a logic end here, and there is no end. There's only one signals, and this is our output signals here. You see, this is our output signals. And output signals, that means the signals is going to the machine, huh? Y1 and Y2. So we have three important sections. One of them is input signals. The other one is signal processing. That means the logic part, how we connect the signals, create the output signals in order to create the output signals. And here we have the output signals. Very important, very interesting actually. And later on, if we talk in hardware and software, you will see in hardware, we will do more, we will use another way. I mean the hardware, the programmable logic controller, and you will see a programmable logic controller will have an input module and output module and signal processing module. And I am showing you here in a simple example. So what means the input signals, what means the output signals. Output signals are the signals on the machine, like the coils, the coils and or the relays, for example, is also the output belongs to the output signal, part of the output signals, and the signal processing part here. Okay, let's come the home and let's operate once more. You see the output signals here, and if I push the button here, first I have to turn on the pneumatic energy turn on, and then if I push the start signals, you see piston moves forward and automatically come back because it is touching the in advanced stroke B1, B2, and then 1B2. You see here 1B2 is activate the coil K3, and K3 has a contact, normal open contact here in this part, and then the normal open contact gets closed, and the Y2 turn on, and then Y2 turn on, the valve take this position, and this position piston moves initial position. So I will change something here. And so how can I do that? I can add start and stop in this circuit. Okay, I can add start and stop in this circuit, like no. Okay, now let's move to the side here, and this also here, and I can move in that direction like this here. Okay, so, and this also I have to move to the left. Okay, so I will add something here. Now you will see. And this is the start, and I will add something more, a stop signal here. Start and stop signals. And the stop signals will be the same like here. This will be stop signal. Okay. And I will add one normal open contact here. We already discussed. I'm in the okay. This is the must be K1. Okay. So this is the K1. Okay. So this is our start. Let's change the name. Start. Let's say that's, where is it? Okay, start. This is start, our start signals. Okay, this is our start signal. Okay, and this is our stop signals, must be. Stop signals. Okay. So you see now, and let's start. Open the pneumatic energy, and I push the start button. What's happening here? Something is wrong. Okay. Okay, I made a mistake. I have to use a normally close contact. Normally close contact is okay. So can I change it? Properties. Normally close. Simulation, no. Simulation is not. I cannot do that. Okay, I take out. Doesn't matter. Let's use the normally close one. Like this. Push button, but normally close contact. So then let's write the properties. Stop signals. Stop signals. Okay. So then start. Okay, let's turn on the pneumatic energy and start the button. And if I push this button, it moves continuously. That means automated system. So when I push the stop signals, it stops at the end of the cycle. But if I don't push the stop signals, it is already it continues to move. So you see the input signals here, and the signal processing part, and the output signals, and this is the power circuit, and this is the control circuit. And you know, this is just a simple circuit, simple automated system, bir automated linear actuator. Linear actuator moves between two end position, the initial position and the advanced position. So if I push the stop button like this, so it will stop at the end of the cycle. So stop at the end of the cycle. Do you have any question? Okay. So by this circuit, I had the possibility to show you what are the input signals, what are the output signals, and what is the signal processing part, and how can we process the signal. Let's say create a logic AND here. So that means logic AND means if I push the start button, and if the this sensor B1B is active, then piston moves forward. If not, piston doesn't move forward. Okay. So then let's make a break. So after the break, we will finalize the lessons for today.
Hello, Doctor.
And all these cables, I mean the cable, are the network. Network, that means provide the signals. So sorry, deliver the signals from the sensor to the control unit, or from the control unit to the machine, to the coils, and so on.
Doctor,
Okay.
my friends sent the presentation on your email.
Yes. You mean the
you are Group C.
electromechanical actuators?
Yes, yes, Group C.
Okay.
Yes, thanks a lot.
So it needs more knowledge about types of electromechanical actuators. You mentioned the hydraulic, pneumatic. There are not electromechanical actuators. There are pneumatic and hydraulic actuators. You have to work on, let's say, this electrical motors like synchronous, and synchronous, and linear, and servo, and so on. Huh?
Okay, then we have to edit it and again send it, or no?
So you have to edit it. Of course, you have to let's say improve.
Okay, for sure. Thanks a lot.
Okay. You are welcome. So let's make a 15 minutes break, and we will start at 20 past 4. Okay, let's continue. Continue with the network. So can you hear me? Is the connection okay? Okay. Thank you. Thank you for feedback. So let's continue then. We were talking about the network, and we said, what is network? What do we mean by the network, and so on. And we have established a circuit consists of one, establish the motion control system consists of one linear actuator, pneumatic linear actuator, and we design the control system for that. We show the input signals, we show the output signals and signal processing and all those things. And we show also that the input and output signals and the control part connected with cables, and those cables are responsible to transfer the signals. And this, to transfer the signals, the network, this is the network, we start to talk about. So network today is in our industrialized world is everywhere. Even in a small companies, you see the network. All the information flowing in the company has to be connected, has to be, let's say, adapted and connected to the network system. Because today's problem is actually there's a huge data, and this data must be processed and must be checked, evaluate, and produce. Maybe using this data, we have to produce the usable data, and the usable data we have to use for the further step in the company. It's not only the control system, also to drive a company. But you see this example here, the network example. If the PCs are networked, lots of PC or the control units are connected to each other, like in airplane, or the PCs, handies, and the others, let's say the buildings, and all around the world. So there's a big network. So let's come to the engineering part. I mean, to the company. So what happens in the company? In a company, we have here in the first floor, let's say the actuator and sensors. We already know what means actuator and what means sensor. We need the sensor to observe, to check the motion of the actuators, and to get information, to the knowledge, to create the information about the motion of the actuator created by the actuators, and deliver this information to these controller units. That means the processing units, and from here into the management information system, like from there to any corner to the world, in the world, and so on. Like you today, you are in a certain location, but you are connected to several corners in the world, and you can get information, you can deliver the information. This is the network. And same here, the first floor of the company, and you see the actuators and sensors, and the second floor, let's say the second step or second stage, we have the signal processing units, and the signal, and we have maybe SCADA, and to let's say to make the data seeable, to draw pictures on graph and all those things, to make it seeable and understandable, and to use for the further step, to decide for further steps. And the same here. So the components networks here, the control level control networks, and the information networks, and so on. But from the down to the top, the information flows to the top, from down to the top, and from down to the top, from the top to the down, top down and down top and so on. The network is, the running signals are running over the networks. So distributed today is very important. Important distributed control, distributed automation system. So you see there are many machines here. You can imagine. So there are many machines here connected via the network, and each machine has its own controller and to control the work done by the machines. The produce maybe something or assembly or test and so on. So all those information has to flow to the information management system or information analyzing station, and there the information has to be analyzed, and by evaluating of this information, the necessary important information has to be created and sent to the management, so that the management can understand so what's going on in the shop floor, which machine produced and how much produced, and breakdown and how long breakdown, and how many at the end of the days we produced and how many are missing, and did we deliver the product to the customer, and how much, and so on. So are we in line with our targets or not, and so on. Huh? All this information has to be connected to each other, and therefore we need a network. So you see also here the distributed automation system. Distributed means each machine, each unit has its own controller, has to do this own work, is not dependent the control system of the others machines, but they have to communicate with each other, so that the communication, the data has to flow from the down to the top. So here we have a computer integrated manufacturing system. Computer integrated manufacturing system means in the down stage we have the sensors and actuators here, and then we have field bus. That means the field bus. The field bus. This is the communications. This is the signals flowing through the field bus. The type of communication system network, and here we have the signal processing unit. Let's say the industrial PCs or PLCs, programmable logic controller, or industrial PCs. And here on the top we have the supervisor level. So management, information system management can sit in front of the computer and can get the necessary information which is important for the management. But today's this is developed, and you can see actually what's happening in the company, not dependent where you are. You can see in each location everywhere in the world. And this is the comforts offered by the communication system and the networks. So this is also is shown as company, and the downstairs we have the machines working and the transfer band and so on. And each machine is work alone, but they communicate each other and they deliver the information to the second floor and the control cabinets and visualization system, SCADA and so on. So if somebody, say the management, has to see what's going on. And the same here, this is the module manufacturing or the assembly on transfer band and so on. And here's standalone machines, and here we have the PLC and small machines and so on. All are connected by the network. And in the machine, you can see there is here valve terminals. So valves is here single valves, and here the valve terminals connected by the multiple to the control cabinet. Here we have the single valve. Each valve has to be connected to the here the small cabinet to the control cabinet. And here we have multiple. There is a one cable, and in this cable there are many cables integrated, and all the cables are responsible for the input and output signals connected to the input and output signals. So we can say the multiple valve terminals and multiple cable here, terminal strip here, and the wires here in the control cabinet, and the PLC programmable logic controller, a type of PC, process the signals. And the same here, but each valve has to be connected individually by the cables. Here we have the multiple. And this is the development of the communication system, network system, from the past to our today's. So from the individual connections, we came to the multiple connections, and from the multiple connections, we came to the bus connections, field bus connection. Field bus connection is on one cable. So via this cable, so all the signals are transferred between valve terminals or any input-output modules in the field, between input-output modules in field between to the control cabinets where we have the PLC. So you see the communication system are changing. So, and now, you know, also today's we are talking about wireless communication. This is wireless. This is wires with wires. I mean, communication via the wire. Now we have wireless communication, as you know. And there are many network systems in the industry, and it is also changing from one to the others. We had ASI connection system, actuator sensor interface, that means actuator sensor interface. We had Profinet, we have DeviceNet, we had the open control interbus and CAN bus. Nowadays we have Profinet and so on. So many signal transferring system, and generally we say field bus, like a bus, but transfer, not the human or the anything, any object, only signals. Signals are transferred. So since we have many field bus systems like Profibus, Interbus, CAN bus, ASI interface, hard and bit bus, and DIN bus, and the Profinet, and all those things, so we have to able to check their let's say possibilities or the properties. So which one we can select or use for our purpose, for our application. So what are the criteria to evaluate a bus system, this network system? So one of them is the length data range. The other one is the number of slaves. And the next one, working principle. And then next one, telegram length, and next one, electrical interface and physical interface, and so on. And also the speed, I mean, transferring the signals. So you see here, we have the Profibus. If you compare the Profibus, check the properties of the Profibus regarding the length, data range is 200 meters. 200 meters, the length 500 kilobytes per second, or 1,200 meters, 9 kilobytes per second. You see, if the distance is getting longer, so the amount of the signals or speed of the signals getting lower. And you see here, you can check it. There are 1, 2, 3, 4, 5, 6, 7 bus systems compared regarding to these properties and so on. The communication interface is the RS485 here. And the physical interface, the twisted pair fiber optic cable, and so on. Here we have twisted pair cable, twisted pair fiber cable, not specified, and so on. Twisted pair and double twisted pair, and so on, for different bus systems. And here you see some examples. I did with my group in my previous industrial work or position. So this is a control cabinet. You see there are some the linear actuators here. This is a fixture and several linear actuators and connected the sensors and for the linear actuators, valves and coils and all those things, as I shown at the beginning of our lessons with the simulator. And it is the control cabinet, and the signals are connected, output signals, input signals, and there is a PLC inside, the PLC or the controller, I don't know. Signals are controlled with the real applications. And here we have, again, the one control cabinet. Inside there is a valve terminal. Here you see the inputs-outputs module, the outputs-inputs module for the sensors. Here we have the valves. And there is a PLC here, and this PLC, this is the signal processing unit. They control the signals, evaluate the signals, process the signals, and so on. And in other applications here, there is a fixture produced for a car company, and it's the control cabinet. All the signals, input-output signals, are connected to the field, or from the field, from the control cabinets to the field, or from the field to the control cabinets. You see here the terminal strip, and here inside the valve and the input-output module and the control unit, and so on. And this is also another control cabinet, new control project. So here we have the PLC here, input-output module, and the valves, and you see the cables, the transferring the signals connected here. This come from the PLC side, from the PLC, and this is from the environment, from the machine. And this is also another fixture, the control cabinet here. You see, I guess was produced for the company, for the Mercedes, I guess. So and the cables you see from here flowing into the control cabinets, and from the signal from the control cabinets to the environment, where we have the coils or solenoids and so on. This is a big one, big control cabinets, relatively big. So we have many valve terminals, and mainly is a pneumatic. We have here the input and output modules here. So the signal, many signals are connected here. You see the terminal with the terminal with the. This is here we use the interbus S. It's another bus system for transferring the signals or for delivering the signals. So another industrial communication system is the ASIBus interface, actuator sensor interface. This mainly used in the band system. We have, so the signals can be transferred from the sensors to the controller via the relative high distance, like 100 meter or maybe more than 100 meters. And each individual signals can be connected to the cable, to the ASI cable. And it's a special cable, and the cable can transfer the input signals and output signals at the same time. and also the energy cable is also involved in this. The energy supply is involved in this cable. And you see here the circuit for Azibus. These are actuators and the sensors, and the station 1 in the station 2, the many sensors, many actuators, and so on. Here's terminal, and here we have station 3, and this is terminal belongs to that, and this is the cable here connected to the AZI via the Azibus here, and is the control cabinets. And we have here the CPU, that means signal processing units, input-output modules, and all the clements here connected, the cables connected to the, and then from this terminal to the input-output modules of the PLC. Okay, so less cable, mainly we say, if we use the AZI bus, we use less cable. So we reduce the amount of the cable. So this is another picture showing the Azibus applications. You see the one, it's a yellow cable, and all sensors and actuators are connected to the cable, and these cables is only one cable connected to the CPU, to the control cabinet, where we have the let's say the Azibus module, and this is the master here. Azibus module is connected to the Azibus module, and that means signals from the CPU going to the field, or from signals from the field, like the sensor signals from the field going through this Azibus into the control unit. And there is another example here. We use the Azibus system as integrated CPU valve terminals here, and many products, pneumatic products, many actuators and signals element, input-output signals, and so on. And here we have also another application, field bus system. Let's say could be Profibus or Profinet, and those are the WAF terminals here connected to the input-output modules. Here, WAF terminal connected to the input-output modules, and you see all signals are connected somehow via the network to the control units, and this we call network. And this industrial network is unbelievable important today. So the blue means pneumatic device, yellow means digital sensors, and the orange means digital actuator, and so on here. And this is the real picture from the field where we applied this technology. Okay, so the purchasing and design comparison of the station-oriented machines. So there are some advantages, of course. He has mentioned it. The comparison of system cost. The CPX is in valve terminal. CPA is the best performer with regards to this type of system structure. What's the reason? Necessary flexibility for input digital and analog, output digital, and the signals could be digital or analog. So, and the valves and optimized product design for machine design. So there's another example here, used also the field bus system. You see, with this picture, I want to make clear that the industrial communication system, the network systems, are used very frequently in the industry. But there are different type of protocol, different type of network system. And you should read about it. And if you later on start somewhere, your professional life, you should check which type of industrial communication system used if you involve in this let's say the topic. So you should check which type of communication system used in the company, and what are the main supplier or the I mean, companies, your company working with them, and you should get fit about it. Okay, against the comparison and there's a handling system. Even if you have a handling system or a transfer band system here, so we deal with many signals. So, and all the signals has to be delivered by the bus system, the network, and of course the safety of the signals is also important, that we get the signals as it is. And the WAV terminals, here you see the WAV terminals. There's a bus connections here. There's another WAV terminal. Here maybe the input-output modules or the terminal again. That means we can connect input signals, output signals, valves, and so on. And all the signals are flowing on one cable and the bus cable. And another WAV terminal you see here, the signals. And here we have the terminal where we have where the PLC input-output modules, maybe analog, digital, and so on, with connected to the field with a bus cable, bus module. And here much more complex. This is the valve part. We have here the valve, the pneumatic valves. Here we have the PLC or the module and PLC and output modules and all those things. All are in the same terminal. And here much more complex input-output modules and bus modules connect to the bus cable to communicate via the bus system. And the valves here also, that means the outputs are also connected. You know, if you have valve, we have outputs. And the coils means output. They work with the output signals. So again, different type of valve terminals. And you see here the Ethernet or Profinet like work this. So we have here all these PLC can be connected to that. Connected nowadays via the Ethernet or Profinet. So if you produce a machine and let's say send to any country in the world, you can contact the machine, the control system of the machine from the location where you are, and you can see what's happened with the machine, if it is a breakdown or trouble with the machine. So you can check why it doesn't work or what is the problem. You can tell the people, so this is the sensor, or this is the relay, or this is the coil, and so on, solenoid, and so on, or anything else. Today it offers very high comfort, I must say. Now, so the distributed control offer us, so this we have a computer or our connection somewhere in the world, and we have a machine somewhere in the world, and machine has a controller, and we can get connections. We establish the connection to the controller, and we can know, or we can get information, or we can deliver something, and we can get information about the machines, what's happened there, produced, not produced, how many produced, breakdown, how long, and so on. And today's we already know. It is, of course, an old picture regarding the handies, but since many years, we use also wireless communication. Wireless communication, like our handy. So now today's technology offers you that you can operate a machine while you are using your handy. So you can operate the machine. You can get the information or the data about the machine and you can check the performance of the machine and also all those things. So this is enough for the network. And we finished also the part of network today. So next week we will discuss, we are going to discuss the hardware, and then later on the software, and we will finish the principle of the mechatronics, the basics of the mechatronics, or basic components and units of the mechatronics. And if we finish all of them, maybe we can design using the simulation software, we can design a mechatronic system, and we summarize all of them, what we learned and why we learned and where we can apply. Okay, do you have any question? So if not, I finish for today. And I wish you a happy and nice week. And see you next week. Huh? Bye-bye.